You can use views to provide data to client applications, and there are a number of advantages to using views. One is that you can give columns in views friendly names to simplify database structures so that users can easily query them. If you have a schema that has very cryptic names, this can make your data more accessible to users. You can also use views to customize data with different filters and sorts for different users or for different applications. A nice thing about views is that the end user or client application doesn't have to know anything about the complexity, join syntax, or aggregates in the query that underlines the view. And you can omit unnecessary or sensitive data from the view. In other words, you don't have to include all the columns in the view results from the tables that comprise the view's source data. And then views can provide a backward-compatible interface to emulate a table that no longer exists or that has had its schema changed. And then you can also export data to another application using a view. And finally, a big advantage of views is that you can use them to partition data based on whatever criteria that you specify. Now, a view is the sort of database object that once you understand how they work and the differences between them and straight select statements, you'll start finding a wide variety of ways to put views to use. One of the major reasons to use a view instead of executing select statements directly is to avoid granting permissions to users on the underlying tables and other database objects that are accessed by the view. You can grant a user or role permission on a view alone, and by doing that, you limit a user's access to the raw data. As long as the owner of the view and the underlying tables are the same principal, then the user is going to have access to the data even without explicit rights to the underlying data within the table. So another way to describe this is that you can revoke all permissions to tables and grant permissions on views that select only certain columns or rows from those tables. Users will then be able to work with the views based on the permissions granted to the views, not the lack of permissions on the underlying tables. So what this does is it gives you far more granular control over the exposure of your data. And that lets you limit data modification so that it conforms to the view criteria. The syntax for creating a view is basically a select statement with a create view as preface that causes a statement to be saved as a view object in the database instead of being immediately executed, like a select statement would be. Only the definition of the view is saved, not the actual data results, unless you create an indexed view. And I'll talk about indexed views in a different part of the course. Now, you have to be granted special permissions to create views. If the view is created with something called schema binding, then you have to have the appropriate permissions on any tables or other views referenced within the view definition. And when we start looking at examples of creating views, this will make a little bit more sense. Now, there are a few rules that you have to follow when you create a view. First thing is that an order by clause is not supported unless the statement also has a top or for XML clause. The name of the view has to follow the rules for SQL Server identifiers, and the name for each view within a schema must be unique. So that's nothing special about views. That's part of the naming scheme within a database. And then nested views can't exceed 32 levels. Now, you rarely need to nest them anywhere near that level because performance will probably be miserably slow long before you reach 32 levels. So do what you need to nest views, but keep it as shallow as you can. Unlike tables, views can't have rules or defaults. Those are handled by the underlying tables. If you want to create triggers, you can only create instead of triggers, a particular type of trigger, because they provide a way to control changes made to the data within tables. Compute by and into clauses are not supported, so those are features of a straight select statement that you can't use within a view. And you also can't create temporary views or views on temporary tables. And then views, tables, or functions underlying a view created with the schema binding clause can't be dropped unless the view is dropped or altered to remove the schema binding. And I'll talk about schema binding a little bit more shortly. And then full text queries can't be issued against a view, although a view can reference a table that is configured for full text indexing. Now that sounds like some pretty onerous rules, but as a practical matter, most of the rules and limitations have to do really just with the nature of views themselves. They're still a very, very useful construct within SQL Server. Now let me talk a little bit more about views and order by. If you're new to views, you may be puzzled to discover that you can't define a sort order as part of the view definition. That's such an inherent part of selecting and retrieving data from SQL Server. But this becomes less puzzling when you remember that views are treated the same as tables, the way you use them from within code. And tables themselves don't have any inherent sort order. You're not guaranteed to get the raw data back from a table in which you inserted it or any other kind of sort order, with some exceptions. So, when you want to sort the data in a table in a particular way when you retrieve it, you need to use a select statement with an order by clause. And that's the same as when you use a view, when you're using a view to retrieve data from underlying tables. Now, as a workaround, some developers have discovered that if you use a top in a view, it does allow you to add an order by clause, and that you can simply use top 100%. But the only reason that the order by is allowed is because it's usually necessary for calculating which top rows SQL Server needs to return. So the top sales. So you sort by total sales in descending order, and you retrieve the top rows, say the top 10% or the top 5 rows or whatever. So in that case, it's necessary to use an order by so that you get the top rows that you want. Now, in a regular query that uses top with an order by clause, the results of the query are returned in the same sorted order that's used to calculate which rows meet that top requirement. So in SQL Server 2000, quite an old version of SQL Server, this was true for views as well. But in SQL Server 2005 and later, up through SQL Server 2012, the order by clause in a view is only used with top to calculate which rows to return. There's no guarantee that the view will return those rows in that sorted order. So you can include order by, but you're not guaranteed that the data returned by the raw view is going to be sorted in that same order. Okay, so be aware of that little gotcha when working with sorted data and views. Okay, so the view syntax. It's really pretty simple. There's the basic syntax. There's a few other little options here and there, but these are the features that you're going to use most often. So you have a create view statement, so that tells SQL Server that you want to define a view object. And then you can include the schema name. Like other database objects, it's going to use the default schema if you don't provide one. So it's either going to be the default schema with my user as I'm logged in, or fall back to DBO if I have permissions on that. And then you give it a view name. You define the different columns that you want to include, and then there's various view attributes. As you can see at the bottom, there's encryption, schema binding, and view metadata. And I'll talk about those shortly. And then you define it using an as clause, and then it really consists of a select statement. The select statement can be as simple or as complex as you want. It can be as simple as select star from a particular table, or you can have multiple joins and group by and just all kinds of different options. So that's the basic statement. The syntax here looks a little bit scarier than it really is in practice, and we'll be going through a number of examples so that you can see exactly how this statement works. The view name has to conform to the rules for identifiers. And, as I mentioned, it has to be unique within each database schema, whatever schema it resides within. You don't have to specify the column names in the view definition. SQL Server, if you don't specify any, SQL Server will default to all of the column names of the underlying select statement. But you have to specify column names if either of a couple conditions applies. If any of the columns in the view is derived from an arithmetic expression, a built-in function, or a constant, then you have to specify the column names. Or if two or more columns would have the same names, which is usually because of a join. You're joining together two tables that have columns with the same name. In that case, you have to specify column names so that SQL Server can distinguish between the two columns. And then the body of the view, which is after the as keyword, is a select statement. Okay, and then you have some additional options. One is the check option. This option prevents saving data to the underlying tables when the data doesn't match the view definition. And so an example of that is this create view, Seattle customers, as the select statement. So in this case, I'm creating a view that is filtering the customers to only return the customers that are located in the city of Seattle. With this kind of view definition, the result is that if you attempt to use this view to update data in the underlying table using a city other than Seattle, you're not going to be able to save that data. So the reason for this is that it makes sure that the data remains visible to the view after the data is modified. Because if you change the city, then the data, that row, would not be returned from this view anymore. Okay, but to have that behavior, you have to use the with check option. Then there are a few other options. One is encryption. With encryption, encrypts the definition of the view in sys.comments. That's a system table that contains the definition of the view. So it encrypts it in order to prevent casual viewing. One problem of using with encryption is that you then can't later modify the encrypted view. So if you use encryption, you should also save your view definition as a script. Now, big warning about this. It's notoriously easy to crack the encryption of stored procedures and views. So this option is more to prevent casual users from easily seeing your code. Anyone that's really determined to see the code and has the necessary permissions on the view is going to be able to decrypt it. It doesn't use any of SQL Server 2012's strong encryption techniques. Okay, so use that with caution. All right, then another option is with schema binding. This option locks the definition of the underlying objects used in the view definition, views, tables, whatever. Once you create the view with this option, you won't be able to drop or make design changes to any of those underlying objects. One side effect of this is that the select statement used in the view definition has to include the two-part name, schema.object, of referenced tables, views, or any user-defined functions. Okay, so this is essentially putting a limit on what you can do, the changes that you can make to the underlying objects when you have a view with schema binding that is built on those objects. Okay, again, you don't use with schema binding, you don't have that kind of protection. All right, and then the last option is with view metadata. And what this does is it returns metadata information to client applications about the base tables and the columns. And what that does is it supports updatable client-side cursors.